In this video, we're going to do one more example of ratios and proportions um, in chemical reactions. So here we have an equation. We have two aluminums reacting with three oxygen molecules to make two aluminum oxides. So think of this like a recipe. Every time you want to make two aluminum oxides, you need to have two aluminum atoms, and three oxygen molecules. So if you want to make four aluminum oxides, you'd need to double everything. So you'd have to do four aluminums and then six oxygen molecules. And so it's just like a recipe for making anything, really. If you want to make a sandwich, you need two pieces of bread, piece of cheese to make one sandwich. If you want to make two sandwiches, you need four pieces of bread and two pieces of cheese to make two sandwiches. So you double the recipe. And that to figure that out, you basically use ratios and proportions. So let's write some ratios to compare the reactants. So for every two aluminums that we use, or that reacts, three oxygen molecules will react with it. So we have a 2 aluminum to 3 oxygen ratio, just 2 to 3 ratio. But again, I like to write down 2 to what to 3 what. Write ratio expressions to compare Al and Al2O3. So when we have two aluminums reacting, we have two aluminum oxides produced. And this is therefore a 2 aluminum to 2 aluminum oxide ratio. But we can simplify this to a 1-to-1 ratio, 1 aluminum to 1 aluminum oxide ratio. So it's simply a 1-to-1 ratio. And lastly, we can compare the oxygen to the aluminum oxide. So you can compare everything to everything in these equations, which is really neat. If we have three oxygen molecules reacting, we get two aluminum oxides. And so this is a 3 oxygen to 2 aluminum oxide ratio. So 3 to 2 ratio. And likewise, we could do some sample problems where if I give you numbers other than 2 or 4 or whatever's in the equation, we can set up ratios and proportions to solve those problems. So suppose that we had produced 6 aluminum oxides. Well, how many O2 must have reacted? And we're assuming we have a perfect recipe here. We have exactly the right amount of everything to make what we need here. So we're comparing the aluminum oxide to oxygen. So aluminum oxide to oxygen, and we're looking for how many oxygens are produced. So I'm going to write the ratio with oxygen on top. So normally the oxygen is, so we have 3O2 over, where are we here? Right here. So C here. 3O2 for every 2 aluminum oxides produced. And so we're going to equate that to what our actual scenario is. Rather than produce 2, we've produced 6 Al2O3s. And so we're looking for how many O2s we're producing. Right away, you can probably see we're producing 3 times more aluminum oxide, so we probably need 3 times more oxygen. Just off the top of your head, think about what that means. So we did times 3, so times 3, we probably need 9 oxygen. But just to show you how that works, we're going to do our cross multiplying, and we get X number of O2 is equal to 3 O2 multiplied by 6Al2O3 over 2Al2O3. These units can cancel out. And so we're left with O2 at the end here. And so we're doing 3 times 6, that's 18, divided by 2, 9. So we have X is equal to 9 O2 molecules must have reacted. And you could have probably done the same thing to figure out your number of Al. And you could actually do the same thing to figure out your number of Al. So let's take a look. So if we have 6 Al2O3 are produced, how many Als reacted? So let's compare Al2O3 to our aluminums this time. Notice it's a 1-to-1 ratio. That's easy. Then if it's a 1-to-1 ratio, it means they're kind of always equal. If you have, one of this, you have one of the other one. So if you have 6 of the Al2O3, you should have also 6 of the Al. But let's just double check that. Let's write our ratio out. So it's a 1-to-1 ratio. We want to find the amount of Al. So we put Al on top, 1 Al, over 1 Al2O3 is equal to 6 Al2O3 times XAL. And notice it's 6 times, right? So 6 times 1 on top would be also 6 ALs. But let's just do our cross multiplication there. So X amount of AL is equal to 1 AL times 6 Al2O3 over 1Al2O3, cross that out there, cross this out here, and we're left with Al. So we got 1 times 6 divided by 1, that's just 6. So X is equal to 6 aluminums. 6 aluminums. And that makes sense when you compare it to the oxygen as well up here, right? That's still a 2 to 3 ratio between the aluminum and the oxygen when you reduce it. So it looks like our recipe is working out. Okay, so if 13 aluminum react, then how many O2 react? Use proportions and ratio to solve. So 13 aluminums react. Compare aluminums and oxygen. So we want to find how much O2 we have. So I'm going to write it like this. My regular ratio for my equation is 3O2 for every 2 Al. And I have 13 Als. And I need to figure out how many O2s I have. So we're going to do a cross multiplication. So we'll get the amount of O2 is equal to 3O2 times 13Al over 2Al. And so we'll cross this out, cross that out, and we're left with X is equal to, so 3 times 13 is 39, divided by 2 is 19.5. So 19.5 O2. O2. Let's erase that, make it neater. 19.5 O2. And I know it seems weird. Do you really have 19 and a half oxygen molecules? Well, this doesn't only have to mean molecules. This can only mean This could also mean something else called moles. And so we can have these half mole values as well, and we'll discuss that later on. But the main point is that we figured out our ratio, and we were able to use our ratio and proportions to figure out how many oxygens that we actually needed. And I think it makes sense if you look at it. It's a 2 to 3 ratio. So if I had 13, so to get from 13 to 2, just thinking out loud here, you have to multiply by 6.5. So 3 times 6.5 is 19.5, right? To get from here to here, I had to do times 6.5, and so that means I also had to do times 6.5 over here, and that would mean it's 19.5. So it does work out if you think about it logically like that as well. And so what we did is we just did an example where we solved some chemistry problems using proportions and ratios, simple ones, with number of molecules. And this is what we're going to be doing for most of the unit, and that will carry through for the rest of the units and also the rest of basically the rest of the course. And also you'll see this in grade 12 in a lot of detail. You're going to have to know how to do these type of calculations in more detail. But don't be too scared right now. You're going to get the hang of it. There's some more practice problems in these videos that you can try out here. There's practice problems that are solved, and so you can test your skills there as well. So go through the examples that we saw through the video lessons and then do these as extra practice if you feel like you need that extra practice.